In this continuation of the Geometry International Honors Summer Assignment Help video series, we're going to work through some examples of multiplying polynomials and factoring. So in this first example, we're going to multiply together two binomials. So we're taking two terms of one binomial times two terms of another binomial. So what we're going to end up doing is just using the distributive property twice. Now in the past you may have used a box method, or perhaps you've used FOIL. All of those are just different ways of organizing yourself so that you make sure that both terms of this binomial get multiplied by both terms of the second binomial. So let's go ahead and start with this 3x, and we're going to distribute and multiply it by both terms of the second binomial. So 3x times x gives us 3x squared, and then 3x times positive 5 would give us positive 15x. So now that we are done distributing the first term, let's move on to the second term, and we will distribute it. We'll multiply it by both terms in the second binomial. So I'm going to take that negative 1 times x, which would give me negative x, and then we're going to take negative 1 times positive 5, which gives us negative 5. Now at this point, these two like terms need to be combined, and we'll do that to get our final answer of 3x squared, and then 15x minus x would be plus 14x, and then minus 5. Now many of you are very competent in going from this step right to the final answer, and that's perfectly fine. In fact, that's really preferable the farther you go in mathematics, in your study of mathematics. But if you need to write it out, by all means do that, so that will help you get to the right answer. In the second example, we are going to be squaring a binomial. Now, when you square a binomial, that's just taking a binomial and multiplying it by itself. So you might be tempted, and in fact it's perfectly okay to do this, to rewrite this problem as 2x minus 7 times 2x minus 7, and then use FOIL method or the distributive method and work it out, and that's perfectly fine. But I want to show you a property, and if you can learn this property, it's going to help you so much in the future. And that is when we take a minus b, anytime we take a binomial and square it, the same pattern is always going to happen. Let's go ahead and let me write this out. It would be a minus b times a minus b. Let's go ahead and multiply by, or I guess the long way. So I'm going to distribute the a, which would give me a squared minus ab, and now let's distribute the b. I'm going to take negative b times a and then negative b times negative b. So I'm going to get another negative ab term, and then that negative b times negative b would be plus b squared. Combining these like terms will give me a squared minus 2ab plus b squared. So I want you to look at that. This pattern will always happen. When we square the binomial a minus b, your answer will always have three terms. The first term will be a squared. That's your first term of your binomial squared. And then the middle term will be the two terms multiplied together and doubled, and of course they would be negative. And then the last term will be the last term, the binomial squared. If we're looking at the binomial a plus b and we're squaring that, your answers will always be of this form: a squared, this time plus 2ab plus b squared. So I encourage you to memorize those patterns, because it makes it so much easier to square binomials like this one. So our answer is going to be a trinomial. We're going to take the first term, 2x, and we're going to square that. Now 2x times 2x will give us 4x squared, okay? And then so 4x squared minus, so I'm going to write a subtraction sign, and then your middle term will be the two terms multiplied together and doubled. So 2x times 7 is 14x. When you double that, you get 28x. And then the last term is going to be plus the second term squared. So our second term is 7, or negative 7 actually. When I squared negative 7, I get positive 49. Now, if you want to stop the video and work this out the long way, Okay, if you want to work this problem out, you should come up with the same answer. But again, I encourage you to learn these patterns of squaring a binomial. And if you can learn those patterns, it will make squaring binomials so much easier for you in the future. Now in example 3, this time we're going to be multiplying a binomial times a trinomial. So FOIL isn't going to work for this. To use FOIL, you have to be multiplying a binomial times a binomial. If you want to set up a box method, you could for this problem. It's just your box wouldn't be a square, it would be a rectangle. It would be a 2 by 3 rectangle instead of a 2 by 2. But again, I just prefer using the distributive property. We're going to take the first term of the binomial and we're going to distribute it. We're going to multiply it by the 3 terms in the trinomial. So let's go ahead and do that. X times x squared gives us x cubed. Then when we take x times negative 2x, that's going to give us negative 2x squared. And then we'll take the x times positive 5, and that's going to give us plus 5x. Now at this point, we are done distributing the first term, so now let's move on to the 3 and let's distribute it. We're going to start by multiplying 3 times x squared. And that'll give us plus 3x squared. Now what I like to do is write it under the term that it's like. We need to be combining like terms anyway at some point. So I just line them up. Then we're going to take 3 times negative 2x. That will give us negative 6x. And then last but not least, we'll take that 3 times positive 5, which gives us plus 15. Now at this point we have to combine like terms, and since I have lined up my like terms, that's going to make it a little bit easier. Our final answer then will be x squared, and then combining the x squared terms will give, oh excuse me, not x squared, this would be x cubed. All right, and then we'll combine our x squared terms. That would give us a positive x squared. Combining your x terms, positive 5x plus negative 6x would be negative x, and then the constant term plus 15. And that's our final answer. Now in these next examples, we're going to be moving in the opposite direction. This time, we'll be given a polynomial, and we'll be asked to factor it. So what we're going to do in example 4 is we're going to take this trinomial and we are going to find the 2 binomials that we would multiply together to get that trinomial. Okay, so I hope it's obvious to you that the first term in each binomial needs to be x, because x times x gives us x squared. So let's go ahead and put an x for the first term of each binomial. And then the next thing I always do is look at this term, or this sign, because this negative 21 is the result of multiplying my 2 constants together. So if I multiply 2 constants together and I get a negative result, what that tells me is that the signs have to be opposite. One has to be positive and one has to be negative. So now what we want to do is find the 2 numbers, one positive and one negative, that when you multiply them together you get negative 21. So again, there are different methods for this. You might just start making a list. What are some factors of 21? Well, I could think of 1 and 21. Well, if one of those are positive and one were negative, they would not total negative 4. So let's try another pair of factors. How about 3 and 7? Okay, now, again, one has to be positive and one has to be negative such that they add up to negative 4x. So I hope that's obvious to you then that the 3 needs to be positive and the 7 needs to be negative, because when we add 3 and negative 7, they add up to negative 4, and when we multiply them, their product is negative 21. So that means that this trinomial will factor into the 2 binomials x plus 3 and x minus 7. Now, of course, you can always check your answer by multiplying these 2 binomials back together again, and when you multiply them, you should get this trinomial back again. Now when you factor a polynomial that looks like this example, I'm just going to write it kind of in generic form, ax squared plus bx plus c. When this leading coefficient is something other than 1, it's a little bit more challenging to factor. But let me show you a method that makes it pretty easy to do. What we're going to actually do is end up using factoring by grouping. And to do this problem using grouping, we're going to start by multiplying our leading coefficient, our coefficient of the x squared term times the constant term. So in this case, we're going to take this 3, which is the coefficient of the x squared term, and multiply it by the constant term. 3 times negative 8 is negative 24. Let's just write it over here to the side. And then what we're going to do is we're going to try and find factors of negative 24 that add up to negative 10. So a little bit of trial and error. You might think of 1 and 24, or 2 and 12, 3 and 8, 6 and 4. Just try factors of negative 24. One will be positive, one will be negative, such that they add up to negative 10. And a little trial and error, you should end up with negative 12 and positive 2. When I multiply those two numbers, I get negative 24. When I add them, I get negative 10. So now what we're going to do is we're going to take this middle term, this negative 10x term, and we're going to break it up into, actually write it as the sum of two terms. Negative 12x plus 2x adds up to negative 10x. So that's how we're going to break up the middle term. So let's start by rewriting the first term, 3x squared. And now instead of writing negative 10x, let's write it as the sum of negative 12x plus 2x. So we'll write minus 12x plus 2x, and then we'll continue with the rest of the polynomial and write minus 8. So now we have a total of 1, 2, 3, 4 terms, and you might recall from your Algebra 1 course, you learned how to factor 4 terms using a method called grouping. What we're going to do is we're going to group the first 2 terms together, and then we're going to group the second 2 terms together. Now when you look at these first 2 terms, what you want to do is find a common factor. And you'll notice that 3x squared and 12x have a common factor of 3x. So we're going to factor that 3x out of just these 2 terms, all right? 3x squared divided by 3x will give us x. And then when we take negative 12x and divide a 3x out of it, then we will get minus 4. Okay, so now if you look at the next 2 terms, if you look at 2x minus 8, let's factor a common factor out of those 2 terms, and that common factor would be a positive 2. So I'm going to write plus 2 and factor a 2 out of just those 2 terms, and that would give me x minus 4. So now take a close look, and you'll see that we have this 2 kind of giant terms. And in those 2 terms, we have a common factor of x minus 4. So that's going to be one of our factors of our answer, x minus 4. And the other one will be what's left when we take the x minus 4 out of each term. When I take x minus 4 out of this term, that's going to leave me with 3x. And when I take or factor a 2x out of, when I factor a 2 out of, when I factor the x minus 4 out of this big term, that's going to leave me with the plus 2. Whoops, plus 2. All right, so that's our final answer. And again, if you don't believe it, you can stop the video and multiply these 2 binomials together. And when you do, you should get these 3 terms back again. Okay, in this last example might look a little bit daunting unless you notice look closely at the trinomial, and hopefully you're going to notice that this trinomial is actually a trinomial that's a perfect square. It actually fits this pattern where it's a squared minus 2ab plus b squared, which of course factors into a minus b quantity squared. Now let me show you how this trinomial fits this pattern. If you look at the first term, 16x squared, you should recognize as a perfect square, and its square root is 4x. All right, and then if you look at the last term, 81, you should recognize that as a perfect square whose square root is 9. Now, if we were to take those two terms, that A and that B, if you will, and if we were to multiply those together and then double them, 4x times 9 is 36. Double that result, you get 72x. So you can see how this trinomial fits this pattern. So it's a perfect square. It's going to factor into a binomial squared. And then how do I find that binomial? Well, remember this A is just the square root of your first term. The square root of 16x squared was 4x. All right, so that first term will be 4x. And then since it's of the form a squared minus 2ab, that means that this sign is going to be minus, and then the last term will be b, which is the square root of your third term. The square root of 81 is 9, and so there you go. That's all there is to it. If you recognize these trinomials that are perfect squares, they're very, very, very easy to factor. All right, so I hope that these examples will help you be successful on this part of the summer assignment where you have to multiply polynomials and you have to factor. And then again, if you have any questions, make sure that you let me know at school and I'll be glad to help you.